Welcome. This is Mr. Anderson with the Chapter 8 Rational Expressions Review. I want to take a look at problem number 6. We're to graph the function f of x equals 2 over x and give the domain and the range. First, I want to take a look at what this function looks like with a graphing calculator. I'll plug this in. We've got f of x equals 2 divided by x. All right, take a look at that graph. We see on this graph a horizontal and a vertical asymptote. So our function gets, as from negative infinity, it's super close to the horizontal asymptote, and then it curves around towards the origin, and then follows real close to the vertical asymptote, which is the y-axis. Gets closer and closer and closer as it goes towards negative, or gets closer to 0, x gets closer to 0. Then on the other side of the y-axis, just barely into the positive x ranges, the function is really close to the vertical asymptote, curves around towards the origin, and then follows along the horizontal asymptote, which is the x-axis. And as we go out to x values that are towards positive infinity, it gets closer and closer and closer to the x-axis, or the horizontal asymptote. All right, so let's go back to our problem here, and we want to draw that function on here. All right, but we want to be a lot more accurate than just that. That's the general look of what we're going to have here. All right, but of course we want to be more accurate than that. All right, first of all, the horizontal and the vertical asymptote. What makes this denominator here 0? We're going to have a vertical asymptote. So where x equals 0, that's going to make the denominator 0. We can't divide by 0. And we get a vertical asymptote there. So we get a vertical asymptote at x equals 0. All right, and I want to draw that on my graph here as a dashed vertical line. All right, so this is a line that my function gets really, really close to, but never touches. And a horizontal asymptote right out here. All right, we're not shifting this graph up or down or anything. You can think of it as 2 over x plus 0. There's nothing out here that's shifting this graph up or down. We have a horizontal asymptote at y equals 0. Y equals 0. So we'll go to on our y-axis to y equals 0 right here. All right, and we'll draw a horizontal dashed line right on top of the x-axis. That's again what our function gets really close to, but never actually touches. And I want some points of accuracy in here. So I want like 2 points to the left of this vertical asymptote, and then 2 points to the right of this vertical asymptote. So I'm just going to make a t-chart here, x and y. And I want to plug in values, not values that are really far away from this, the intersection of these asymptotes. If I had values way out here, x equals negative 20, x equals negative 15, that's not really going to tell me much. I know it gets really close to the horizontal asymptote. Same out here. I know it gets really close to the horizontal asymptote out here. Right? What I want are numbers generally in this area right here. And as we play around with these graphs, we get better ideas of what kind of values we want in order to make a little bit of accuracy for this graph here. I'm going to plug in where x is negative 1, x is negative 2, and we'll see on the calculator. I'll pull up the table on the calculator. We'll see where x equals 0, the calculator is going to say error because that's our vertical asymptote. And I want values for x equals 1 and x equals 2 as well. So I'll plug those in, -2, -1. At 0, we're going to see the calculator will say error, and then 1 and 2. Now, what are those y values? Now, actually, well, these are easy enough to plug in. We can plug these in, these x values, and see what y equals, or I guess I could have wrote f of x here rather than y. 2 over -2 would be -1. 2 over -1 would be -2. There's our vertical asymptote, and 2 over 1 is 2, and 2 over 2 is 1. But I want to pull these up on the table just to make sure that you are able to use your tools here. I'll turn this on. All right, so right above graph is table. I want to hit second graph, which is the table, and I'm going to bring up here. And we'll scroll up a little bit. All right, so here's the x values. This is our t-chart right here. And here's the numbers that I plugged in. -2, -1, 0, we see error, because that's where the vertical asymptote is, and then 1 and 2. And these are the values that were easy enough to calculate in this simple rational equation here. We've got -1, -2, 2, and 1. All right, so let's plot these points for some accuracy. -2, comma, -1. So 1, 2, comma, -1 right here. And then -1, comma, -2 right here. 1, comma, 2, 1, comma, 2, and 2, comma, 1. 1, 2, and up 1. All right, and then I want to draw my graph. I'll do that in black here. All right, so like I was saying, out here, as you get closer and closer to towards negative infinity, you get closer and closer to this horizontal asymptote, but never actually touch it. And I want to show that I'm really close to this horizontal asymptote, never touching it, and then I kind of pull away from it a little bit. I curve through, I hit these 2 points, and then I curve around and get closer. I'm trying to draw this accurately, closer and closer to the vertical asymptote. All right, and the other end of the vertical asymptote, same thing. I am really close to that vertical asymptote, and then I just kind of pull away a little bit. I go through these 2 points that I have on there for accuracy, and then as I go out towards x values of positive infinity, I get closer and closer to that horizontal asymptote. All right, so what I've got here on the graph, I've got the general shape that we saw at the very beginning. I've got my vertical asymptote right there at x equals 0. I've got my horizontal asymptote at y equals 0. And then I also have a couple of points of accuracy for our graph. Now it also says, what's the domain and the range? Well, we've got our x values. Where does our function exist for the x values and the y values here? As we see that we are going from negative infinity here towards positive infinity, right, our function exists everywhere except right here at x equals 0. There's a little hole there. Our function never touches that. And then as we go out towards positive infinity here, all right, our function exists. Here's negative infinity out here. All right, so we could write from that. There are a couple different ways we could write this, but we'll say these values are all real numbers. All real numbers except 0. That's where that hole is, right where that vertical asymptote is, except 0. All right, and then as we go from on the y values, let's start down here. We start at negative infinity on the y values, and we go up towards positive infinity. Again, we have this little hole right here at y equals 0, and going up and up and up towards positive infinity. So we see we have the function everywhere except for right here at y equals 0. So again, we have all real numbers except right where y equals 0, except 0. All right, I got that and that. All right, hope this was helpful.